Okay, let's unpack this. We have a dense stack of sources today.
A really dense stack.
And it's not, a sprawling collection of disparate articles, but one extraordinarily focused digesting that, it serves as a single high-resolution snapshot of the future.
That's a great way to put it. It's a snapshot.
It feels like the entire global AI landscape just accelerated by about 5 years in a single news cycle.
It's an overwhelming volume of focused advancement. And what this digest really captures, I think, is the velocity and the breadth of the change.
Yeah.
We are looking at concrete evidence that artificial intelligence is not just optimizing existing processes anymore.
Right. It's not just about efficiency.
No, it's actively pushing boundaries and creating entirely new capabilities across wildly divergent sectors. And the key is, it's all happening at the same moment.
Exactly. So our mission, for you listening, is to provide the ultimate shortcut. We're going to quickly but thoroughly dissect this material to understand the true impact of this velocity. We want to deliver those, those aha moments.
And the context behind them.
Yes, and the deeper context, you need to be genuinely well-informed without the crushing weight of information overload.
And we have to respect the scope here. We are traversing the entire human experience in this one deep dive.
We really are.
Our journey takes us from areas that demand absolute life-critical precision, fields where a decimal point error can be fatal.
Literally life and death.
All the way to the highly subjective and emotional world of creative expression where the rules are fluid and, intent is paramount.
That sets our agenda perfectly. So we're hitting 5 major fields documented in this comprehensive digest.
Let's lay them out.
We start with the high-stakes world of healthcare and the analytical precision required in the legal domain.
Right, the objective fields first.
Then we shift gears to physical mobility with autonomous vehicles and the highly personalized environment of education.
Moving from the professional to the personal.
And finally, we wrap up in the realm of the subjective, the creative arts. It's an intellectual journey from what the pathologists slide to the mixing board.
I love that. Let's do it.
Let's jump in.
Yeah.
So, starting at the deep end with life-critical fields, we're looking first at a truly groundbreaking study coming out of MIT.
This one really stands out.
This isn't just incremental lab progress. This feels like a fundamental redefinition of AI's role in clinical diagnosis.
I agree. This news is foundational, particularly for oncology and diagnostics. The core detail is the development of a highly specific AI model.
And what's it doing?
It's capable of diagnosing certain types of cancer directly from medical imaging.
Okay, but we've heard about that before. What makes this different?
Well, crucially, the sources emphasize that this wasn't just a proof of concept for easily identifiable patterns, like a very obvious tumor.
Right.
This was a successful model targeting subtle early-stage malignancies, the kind that are incredibly difficult to spot.
And the competitive metric here is just staggering. The quantitative insight is that the model achieved an accuracy rate
Go on.
rivaling that of seasoned pathologists.
Think about that for a second. We're talking about highly experienced professionals with decades of nuanced training looking at slides day in and day out.
To reach that level of proficiency means the AI is doing more than just, summarizing data or finding a dot on a screen.
Absolutely. It's performing synthesis at an expert level.
So it demands that we ask, how? How is it actually working?
Well, we're looking at a very sophisticated form of deep learning. Most likely, it's employing highly specialized convolutional neural networks, CNNs for short.
Okay, break that down for us. What's a CNN doing in this context?
So these systems are designed specifically to process visual data in layers. They learn what are called hierarchical patterns.
Really?
Meaning, in this medical context, the AI isn't just looking at the shape of a single cell. It's looking at the texture of the cell cluster, the intensity of the stain used on the slide, the spatial relationship between abnormal cells and the surrounding tissue matrix. It's seeing the whole picture.
So it's analyzing what a human eye might see, but also processing features that are, too subtle?
Too subtle, too varied, or just too vast in quantity for a person to register consistently across thousands of slides.
Doesn't get tired.
It never gets tired. I mean, think about a human pathologist. They rely on visual recognition developed over years, right? But they are limited by processing speed, fatigue, and the inherent variability of how tissue samples are prepared and stained from lab to lab.
So different labs might have slightly different colors or thicknesses on their slides?
Precisely. The AI, on the other hand, having been trained on petabytes of highly heterogeneous medical images from different labs, different countries, different staining protocols,
You can see past that noise.
it can find the invariants, the true underlying markers of disease that are often masked by what we'd call human visual noise. This capability to handle vast, messy, real-world data is the mechanism that allows it to rival human performance.
So what does this new level of accuracy actually mean for the patient pathway? I mean, for you listening, if you go to the hospital, it sounds like the immediate implication is a revolution in the clinical workflow.
It is. The significance of this achievement is the potential to dramatically speed up diagnosis.
Which means you can start treatment faster.
Exactly. And accelerate treatment planning. In cancer care, timely intervention is absolutely paramount. A delay of weeks can change the entire prognosis.
So you can imagine a system where the AI performs the first pass on every single slide that comes in.
A first pass or a second opinion on every single case. It could effectively triage the most complex or the most urgent cases immediately, flagging them for human review. It becomes a tireless, high-precision detection layer that works 24/7.
Removing those critical bottlenecks that you always hear about, often caused by specialized staffing limitations.
You might only have a few top-tier pathologists in a region. This AI gives every hospital access to that level of expertise.
But I need to challenge this notion of rivaling. If it's performing as well as a seasoned expert, why is the source so insistent that the AI must only complement and not replace the human? Where is the friction point there?
And that is the crucial nuance that our listener really needs to grasp. It's the most important part of this story.
Okay.
The AI is a specialist in pattern recognition. It is agnostic to the patient. It doesn't know the person.
Right, it just sees the slide.
Its training data, no matter how vast it is finite. The seasoned pathologist applies nuanced judgment that extends far, far beyond the image on the slide.
Can you give us a concrete example of that nuance? What does that really look like?
Okay, so consider the full context. The AI sees a suspicious cluster of cells. The pathologist sees that same cluster, but also knows the patient's age, their genetic history, known comorbidities like diabetes or heart disease, and critically, whether this finding on this one slide aligns with all the other diagnostic tests, blood work, MRIs, patient-reported symptoms.
The AI model can't ethically or safely integrate all that complex, messy, non-image data.
It's not designed to. Furthermore, the pathologist must act as the critical quality control. What if the image was poorly prepared? What if there was an artifact, a speck of dust on the slide that confused the AI?
Or a really rare presentation of a disease.
Exactly, an incredibly rare presentation that deviates significantly from its training set. The human must have the expertise and the authority to override the machine's prediction.
And the accountability.
That's the key. The pathologist maintains the ethical and legal accountability for the diagnosis, which the machine cannot and should not bear.
So the human role evolves from being the primary detector, the person staring through the microscope for 8 hours a day,
to becoming the ultimate validator, the integrator of all this data, and the accountability layer.
They're the ones synthesizing the high-precision machine data with the messy reality of human biology and patient care.
And that synergy is where the true value lies. It's not human versus machine, it's human plus machine.
Synergy indeed. Okay, let's transition now from biological diagnostics, analyzing cellular patterns, to documentary diagnostics.
I like that phrase.
The legal domain, where the task is still pattern recognition and synthesis, but applied to mountains and mountains of text.
This is a perfect pivot because the cognitive challenge is almost perfectly parallel. Identifying key markers, key phrases hidden within an overwhelming data volume.
And here we are focusing on a startup called LegalEase and their AI-driven platform. It's designed to disrupt, traditional legal research.
And legal research is an area that is ripe for disruption.
The legal world has always struggled with scale, right? Every new case, every merger, every piece of legislation means more paper, more documents to review.
It's an exponential growth problem.
So LegalEase relies heavily on sophisticated natural language processing, NLP. Specifically, the sources mention advanced transformer models. But what makes the legal application of NLP so uniquely challenging compared to, say, having a casual conversation with a chatbot?
The difficulty lies in the The ambiguity and, at the same time, the extreme specificity of legal language.
That sounds like a contradiction.
It is, and that's the problem.
Oh.
Legal text is deliberately dense, it's often archaic, and it's highly, highly contextual. Jurisdiction matters immensely.
Give me an example.
Okay, so the phrase reasonable person. What a reasonable person means in California contract law is demonstrably different from what it means in New York tort law. The AI has to understand that context. It can't just know the definition.
So how does LegalEase's platform handle that?
It uses NLP not just to read words, but to understand legal intent. And that requires training the model on massive annotated data sets of successful litigation, failed litigation, and historical contract interpretations to learn those nuances.
Wow. So that's a huge step beyond a simple keyword search.
It's a different universe. Its primary function is the monumental task of sifting through thousands of legal documents, briefs, contracts, discovery materials, depositions in seconds.
This used to be the domain of hundreds of billable hours from junior associates, right, sitting in a room with boxes of paper.
Exactly. The first and second year associates.
Yep.
Now, the machine does the cognitive heavy lifting of that initial document review instantaneously.
The sources highlight two specific high-value outputs from this platform. Let's delve into what those mean practically for a working law firm.
Okay, the first one is identifying relevant case law.
Right.
So imagine you're a lawyer and you need to defend a client on a very specific patent infringement claim in, say, the Eastern District of Texas, which is a very particular jurisdiction for patent law.
Okay.
Instead of spending a week, maybe longer, manually querying legal databases like Westlaw or LexisNexis, the AI can instantly correlate the specific facts of your current case with the most pertinent precedents, including obscure, decades-old rulings that a human might easily miss.
Because no human can remember every case ever decided.
Not a chance. The AI can. And it can rank them by relevance to your specific fact pattern.
Okay, and the second output they mentioned, extracting key clauses from contracts.
This is absolutely critical for transactional law mergers, acquisitions, venture capital.
How does that work?
The AI doesn't just pull out a section labeled indemnification. It analyzes an entire contract portfolio, say, across 50 different vendors a company works with, and it flags every single instance where the liability caps or the termination clauses deviate from the firm's standard risk profile.
So it's not just finding the clause, it's interpreting the risk associated with it.
Yes. It contextualizes the clause within that specific jurisdiction and that business relationship, effectively identifying hidden risks that are buried deep in boilerplate language that most people just skim over.
I see the immediate benefit, increased efficiency and massively reduced overhead costs. But let's play devil's advocate here. If I'm a partner at a big law firm, my biggest concern beyond efficiency is risk. What if the AI misses a crucial distinction in the language, a single misplaced comma that costs the firm or the client millions? That's the friction.
That is precisely the friction point. It's accountability and accuracy and ambiguity.
Because legal text is designed to be argued over.
Exactly. It's inherently adversarial. So the AI's interpretation is only as reliable as its training data. If the AI hasn't seen a novel statutory interpretation from a court just last week, it can fail. It can miss that nuance.
So this is why the broader context shows the future of legal work is clearly moving towards human-machine collaboration. The machine isn't replacing the lawyer.
Never. But the human remains the point of final synthesis and, crucially, of strategy.
So the lawyer is no longer the human search engine. What is their new task? What do they do all day?
They are the strategic architect. They spend their time focusing on the one thing the machine absolutely cannot do, applying the law strategically to a client's problem.
Which includes things like
developing the compelling narrative for a jury, arguing the specific nuance of a case in front of a judge, engaging in high-stakes negotiation with opposing counsel, and, crucially, managing the client relationship, which is built on trust and empathy.
things a machine can't do.
The human lawyer uses the AI's instant synthesis to validate their own legal theories and focus 90% of their time on those high-value, uniquely human tasks, rather than spending 90% of their time on document discovery.
So the lawyer handles the wisdom in the narrative, and the AI handles the sheer volume of information.
It's a highly efficient, and I would argue a much more effective, division of labor.
Okay, let's pivot now from the professional services of the office to the physical world.
Out onto the open road.
Mobility and transportation. We move from documentary diagnostics to the complex physics of autonomy.
Autonomous vehicles, or AVs, have been on the horizon for, a decade now, maybe more.
Feels like it.
But the advancement detailed in this digest marks a genuine milestone in real-world application. It's proof that the AI is really starting to mature.
We're looking at a major automotive company's announcement detailing their latest AI-powered vehicle. And the specific achievement that caught our attention, and I think everyone's attention, was the successful completion of a cross-country journey.
Right. Not on a test track, not in a simulator.
On real roads, with minimal human intervention. And when they say minimal, the source is clear. They mean only for the necessary regulatory handovers or, maybe a really unusual situation, not constant monitoring.
And you have to understand, this is far more complex than just driving on a straight, empty interstate in Arizona.
Right.
A cross-country journey requires the AI to handle a vast array of challenges, dynamic weather, going from sun glare in the desert to a sudden rainstorm in the mountains.
Navigating unmapped construction zones which pop up overnight.
Handling unpredictable human drivers in complex urban environments like Chicago or Los Angeles. And seamlessly transitioning between different speed limits and traffic laws as you cross state lines.
It's a monumental demonstration of robust AI capabilities.
It really is.
So what specifically does this demonstrate about the advancements in the vehicle's AI? What's new under the hood, so to speak?
It signals a real maturity in two key areas. The first is sensor fusion.
Okay, what is sensor fusion?
It means seamlessly integrating the input from all the different sources on the car LiDAR, which gives you a precise 3D map of the world.
The spinning thing on the roof.
That's the one. Then you have radar, which is great for judging the speed and distance of other cars. And of course, high-resolution cameras for classification, telling a pedestrian from a bicycle, and for reading signs.
And the AI has to process all of that at once.
In real time. These are massive, sometimes conflicting streams of data. The AI is now advanced enough to fuse them together to create a single, reliable, consistent model of the world around it, even if one sensor is temporarily blinded by rain or sun.
Okay, so that's sensor fusion. What was the second area?
Predictive modeling. And this sounds like the key to handling human unpredictability.
It absolutely is. Humans are chaotic. We're irrational drivers.
We are. The AV's AI is no longer just reacting to immediate stimuli, like the car in front of it braking.
It's thinking ahead.
It's running thousands of simulations per second to predict what the car in the lane next to it is likely to do based on its speed, its trajectory, its position in the lane, and the local environment. Is there an exit ramp coming up? Is there a slow truck ahead of it?
So it's planning its movements several seconds ahead.
Which is critical for making safe lane changes or reacting to someone else's sudden braking before it even happens. This level of prediction is what really distinguishes the more advanced levels of autonomy.
That achievement truly marks a pivotal step toward making autonomous cars a reality for the masses. But let's get into the friction points, because I'm skeptical about the claim of minimal intervention when we consider the chaotic infrastructure of the real world.
As you should be.
What about situations that just break the AI's model? Extreme unmapped weather events, a flash flood, a tree falling in the road.
That skepticism is warranted, and the source addresses the challenges specified quite directly. The technology may be capable of the journey 99% of the time.
But that 1% is a killer.
Exactly, and the regulatory and safety hurdles before mass adoption are immense. We are talking about the non-technical issues now.
Such as?
Liability, the big one. If that AV operating with minimal human input causes an accident, the legal and insurance framework is currently completely insufficient.
Who do you sue?
Right. Is the fault with the owner, who wasn't driving, the manufacturer of the car, the programmer who wrote the software, or the specific AI model update that was pushed out last Tuesday?
We don't have answers for that.
We have no answers for that. And until we have clear federal and international safety standards for AI decision-making, for instance, how an AV should prioritize risk in an unavoidable collision, the classic trolley problem.
Right. Does it hit the pedestrian or swerve and risk the occupant?
Until that is codified in law, mass rollout will be halted. The hardware is ready. The legal and ethical structure is not.
So the human oversight shifts from steering the wheel to designing the ethical decision tree for the machine.
And then legislating that decision tree into law, a much harder problem.
Precisely. And there's the public trust element too, isn't there?
Huge. Consumers need to be convinced, not just with data but emotionally, that the AI is safer than a human driver. That requires exhaustive, verifiable testing that goes way beyond a single cross-country trip.
And we have to overcome the hurdle of the uncanny valley in driving.
Explain that.
The idea that the machine drives too perfectly, in a way that sometimes confuses or frustrates the human drivers around it, it follows the rules too precisely.
It doesn't have that human touch, that ability to make eye contact and wave someone through.
Exactly. But so what for you, the listener, here is profound. This is not just about convenience, about reading a book on your commute.
Not at all.
This fuels the excitement about the potential for safer and more efficient transportation.
Safer because AI doesn't text and drive, it doesn't get drunk, it doesn't have road rage.
And more efficient, because a network of AIs can manage traffic flow at a citywide scale far better than millions of individual, selfishly optimizing human drivers all hitting their brakes at once.
It points to a complete re-engineering of urban planning, logistics, and how we live our lives.
Okay, so moving from physical autonomy on the road to intellectual autonomy in the classroom. How AI is shaping personalized learning in education. This application feels intensely personal.
It does, because it targets individual cognitive development right from the earliest stages.
It's a complete paradigm shift away from the factory model of education. One teacher, 30 kids, one lesson plan for everyone.
We are reviewing a recent initiative by an educational technology firm that introduced something called adaptive AI tutors.
And the promise here is just huge. We're talking about AI tutors capable of adapting lessons to individual student needs.
In real time.
This means ending that classic cycle where some students get bored waiting for the class to catch up, while others fall behind because the instruction moved too quickly for them.
The underlying mechanism for this adaptation is what's so fascinating. These tutors utilize predictive analytics and something called Bayesian modeling to assess a student's cognitive state.
What does that mean, cognitive state?
It means it's not just looking at whether an answer to a math problem is right or wrong.
Right.
It's assessing the pattern of errors. It looks at the time taken to respond. It cross-references the student's success on related foundational concepts from previous lessons.
So if a student gets a physics problem wrong,
the AI doesn't just say incorrect, try again. It might diagnose that the student didn't actually misunderstand the physics principle, but that they have a persistent weakness with algebraic manipulation, a skill they were supposed to learn 2 chapters ago.
So it's constantly diagnosing the root cause of the difficulty and offering real-time, tailored feedback.
Precisely.
What does that tailored feedback actually look like in practice for the student?
It moves way beyond just standardized text. For example, if a student is struggling with the concept of fractions, the AI might generate an alternative explanation using visual, pizza-based analogies if it detects the student is a visual learner.
I could have used that.
Me too. Or it might offer a step-by-step spoken explanation if they respond better to auditory instruction. It adjusts the difficulty of the next task instantly, preventing frustration and keeping the student in that optimal zone of proximal development.
The sweet spot for learning.
Exactly.
And the observed impact is already showing promise. The sources say it's enhancing student engagement and comprehension, particularly in those really foundational building block subjects like math and science.
And that's the key, because failure to grasp foundational math concepts in 3rd grade means a student is perpetually handicapped when they get to algebra in high school. It's a cumulative deficit.
The AI acts as an instant safety net.
It ensures those gaps are closed immediately through hyper-targeted intervention, which is something a single human teacher managing a class of 30 students simply cannot physically achieve for every single child.
But this must be terrifying for teachers who fear being replaced by a machine. What does this mean for the role of the human educator?
And this is another parallel to what we saw in law and medicine. The sources make it very clear that the role of teachers may evolve profoundly, but not disappear.
They evolve from traditional instructors who just deliver content
to facilitators of personalized learning experiences. The human teacher's highest value is retained and, I would argue, amplified.
So let's define that facilitator role practically. What does the human teacher focus on when the AI is handling the content delivery and the instant assessment?
The human focuses on the uniquely non-algorithmic high-level skills. The teacher leads collaborative, project-based learning, where students have to synthesize information from multiple sources, defend their arguments, and engage in critical debate.
Skills the AI cannot evaluate or guide effectively.
Exactly. They focus on socio-emotional learning, managing classroom dynamics, addressing a student's motivation or anxiety about the subject, and mentoring genuine curiosity.
The pastoral role.
Yes. They also become the curriculum curator, selecting the best AI tools and models for their specific student population, and, importantly, ensuring equity and accessibility in how the technology is used.
So the teacher shifts from being the distributor of information to being the engineer of human connection and critical thinking.
The machine handles the mechanics of knowledge transfer, and the human handles the cultivation of wisdom and empathy.
That's a powerful new model for education.
Well,
We've covered objective truth in diagnostics, efficiency in law, safety in transportation, and targeted learning in education. Now, let's make the most challenging transition of all.
into the gray area.
Moving into the subjective, the emotional, the realm of the creative arts.
This is where the debate gets truly sticky. Because we are asking AI to operate not just efficiently, but meaningfully. We are talking about art, and specifically in this digest, we're talking about music.
The specific project detailed is the unveiling of a new, highly sophisticated AI composer. I'm curious, what is the underlying technology here? Is this just, stitching together samples of old songs?
Far from it. This composer utilizes sophisticated deep learning models, often variations of what are called generative adversarial networks, or GANs.
GANs.
I've heard of those.
They've been trained on vast libraries of music. We're talking everything from Bach to Billie Eilish.
The AI doesn't just mimic or copy, it learns the underlying rules of musical structure.
Things like harmony, rhythm.
Harmony, rhythm, instrumentation, musical form, and then it generates completely novel compositions that either adhere to those rules or, more interestingly, strategically break those rules in creative ways.
So its capability range is massive. The source says it can compose original music in various styles, from intricate four-movement classical symphonies to 3-minute, radio-ready modern pop hits.
It's an instant genre shifter. A musician could say, give me a film score that sounds like John Williams meets Daft Punk, and it could generate 10 options in a minute.
That's an incredibly powerful tool for utility. I can see that.
For sure. Imagine a film composer on a tight deadline needing 20 minutes of atmospheric background score. The AI can generate hundreds of high-quality, fully orchestrated tracks overnight.
Saving hundreds of hours of human composition time.
And that's why musicians and producers are already integrating it. They're using it to generate fresh ideas, to get over writer's block, to fill out arrangement gaps, or to collaborate on new works, treating the AI as a co-writer with limitless technical proficiency.
But this is where we run straight into the philosophical debate that the source explores so well. If the music sounds objectively good, if it's catchy, does it matter if it was written by a circuit board?
And here you have the two camps. On one side, you have the purists.
What's their argument?
The purists argue adamantly that AI lacks the emotive depth and, critically, the necessary lived experience of human composers. Music, in their view, is an expression of human consciousness, of trauma, of joy, of cultural specificity. An algorithm can manipulate patterns perfectly, but it cannot express intent or suffering or love.
Therefore, the output is technically flawless, but essentially emotionally hollow.
It's simulation, not sincerity. That's their core argument.
But then you have the proponents
Yes.
who look at the practical application and, more importantly, the listener's response.
Exactly. They argue that the utility of the tool and the impact on the listener are what ultimately matter.
If it moves you, it moves you.
If an AI writes a piece of music that genuinely moves a listener, that evokes nostalgia, that inspires a filmmaker to create a scene, then the origin of the code becomes irrelevant.
They view it as an accelerator.
A tool that democratizes musical creation and allows human artists to transcend their technical limitations, pushing innovation in genre blending and sound design.
And this brings us back to our overall analysis for the day. If AI can achieve life-saving objective accuracy in healthcare, where the standard is empirical proof, perhaps the debate in the arts is less about the machine's capability and more about our definition of art itself.
That is the essential conflict we have to confront. In diagnostics, we ask, is it true? In law, we ask, is it accurate? In art, we ask, is it meaningful?
And if the line between AI-generated meaning and human-generated meaning becomes indistinguishable to the listener, does the purist argument even survive?
Or does the very definition of composer or artist expand to embrace the person who curates, guides, and selects the best AI-generated output?
The human role here shifts again.
It shifts to being the ultimate editor, the producer, the final authority on aesthetic choice and commercial viability. The human brings the taste and the context.
We've covered so much ground today, from the microanalysis of cancer cells at MIT and revolutionizing legal synthesis with LegalEase.
It's a macro challenge of autonomous cross-country road trips.
And personalized educational pathways in foundational subjects. And finally, the high art of generating symphonies and pop hits. The sheer scope of AI's simultaneous advancement is truly breathtaking.
It really is.
So what does this all mean when we synthesize these 5 disparate yet interconnected sectors? What's the big takeaway?
I think the primary definitive conclusion from this entire digest is that AI is not a singular technology impacting one little niche.
It's not just for tech companies.
No, it is a general purpose, accelerating capability that is synchronously entering every single domain of human expertise. It is forcing a global reassessment of where machine capability ends and where the unique value of human contribution begins.
The sources leave us with a powerful shared understanding. As these technologies evolve and the adoption hurdles, the legal, the ethical, are overcome, they promise to fundamentally reshape our world.
And in ways we are only beginning to fully grasp. The next decade is less about invention of new AI and more about the integration of the AI we already have.
And that's the crucial element for you, our listener. Understanding this rapid, multifaceted change is no longer abstract knowledge.
It is essential to navigating your professional life and staying ahead of the curve.
Whether you are a lawyer struggling with client data security, an educator adapting your curricula, or just a consumer relying on new transportation safety standards.
The foundational structures of your world are being re-architected right now. You need to know the capabilities of the machine to define your own essential human role alongside it.
Which brings us to our final provocative thought for you to consider. And it builds directly on the dichotomy we've explored today. We have seen definitive proof of AI's capability in 2 fundamentally opposite areas.
On the one hand, we have the machine demonstrating high-stakes, life-saving accuracy in objective analytical fields like healthcare. It can diagnose patterns that humans miss based on hard, verifiable data.
And on the other, we have the machine generating original subjective creativity in the music industry, composing symphonies and pop hits that elicit genuine, emotional human responses, operating in a field where the standard is inherently fluid and aesthetic.
So, here is the question we want to leave you with. Given that AI is proving capable of both high-stakes, life-saving accuracy and producing emotionally resonant, original, subjective creativity, how will we define and maintain the necessary human role in the rapidly changing professional and creative landscape?
If the machines can perform the most complex analytical tasks and simultaneously the most delicate creative tasks, what is the ultimate non-replicable human commodity? The answer, I think, woven throughout all these sources lies in the human capacity for nuanced judgment, for emotional context, for strategic application, and for the ultimate accountability that comes with applying those outcomes to messy, unpredictable human lives.
Defining the boundaries of that human-machine synergy will be the critical task facing all of us in the years to come.
Thank you for joining us for this deep dive into the future of AI.
We'll catch you next time.